Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to day 56 session. Today we are just going to discuss about Python generators. See, actually, there is a lot of work in building an iterator in Python. We have to implement a class with that is a double underscore iter method and a double underscore next method. So keep track of internal states and rise and stop iteration when there are no values to be written. So this is both lengthy and counter-initiative. So generator comes to the rescue in such situation. So Python generators are a simple way of creating iterators. All the work we mentioned above are automatically handled in generators, that is the Python generators. And see here, dear friends, when on just making, that is simply speaking, an generator is a function that returns an object, that is iterator, which we can iterate over, that is one value at a time. And next, let me just see how to generate a, or create a generators in Python. See, I have just specified here. It is a fairly simple to create a generator in Python. It is easy as defining a normal function, but with a yield statement instead of the return statement. And see here, dear friends, if a function contains at least one yield statements, that is, it may contain other yield or return statements also, so it becomes a generator function. Both yield and return will return some values from a function. So the difference is that while a return statement terminates a function entirely, yield statements passes the function saving all its states and later continues from there on successive calls. So that is the main thing for this yield function. Okay, let me just make a difference between the generator function and the normal function. See, here we are just having an how to make a function, that is generator functions differ from the normal. The first one is generator functions contains one or more yield statements. That is what the main thing which we just make as a differentiate. And when called, it returns an object, that is iterator, but does not start execution immediately. So methods like that under double underscore iter or double underscore next are implemented automatically, so we can iterate through the items using next statement. So once the function yields, the function is passed and control is transferred to the caller. So local variables and their states are remembered between the successive calls. And see here, finally, when the function terminates, the stop iteration is raised automatically on the further call. And let me just see here is an example that we are just going to make a generator function as mygen with several yield statements actually. So when a generator is there, at least one yield should be there. So let me just have some several yield method. And here this is my function, that is generator function mygen, and here we are having 1, 2 and 3 return statements, or instead of return we have just specified yield statement. And see here, dear friends, when on just making this an interactive run in the interpreter is given. The interactive run is in the sense that is the run this in the Python shell to see how the output would be is that is we have to call a let I just execute it and I just show you. See here, this is the exact printed first, and we have to give the exact functionality. And when on just making this to be executed, see here, this is the printed first, this is the printed second, and this is the printed third. It just says specify. But when on making it inside the functionality, that is the Python shell, here we need of track or most recent calls that, and we have to initiate a stop iteration. And for your thing, one interesting thing to note in this exact example is that the value of variable n is remembered between each and every call. And unlike normal function, the local variables are not destroyed when the function yields. So furthermore, the generator objects can be iterated only once. So to restart the process, we need to create another generator object using something like a is equal to myGen function, like that we have to make use of it. Okay, let me just have this, dear friends, and see a more elegant way of automatically iterating is by using this for loop. And using this, we can iterate over any objects that can return an iterator. For an example, it can be a list or a string or a file, etc. Okay, let me just move on to next one, Python generators with a loop. See, the above example is of less use, and we studied it just to get an idea of what was happening in the background. So normally generator functions are implemented with a loop having a suitable terminating conditions. So let's take an example of generator with some reversing a string or like that. And see here, dear friends, here we are just having a string, and that string we are just getting it from the user as my string, and it has a range of that length where it is made as like a reversing order, and it's just going to return it in the reversing. And in this example, we have used the range function here to get the index in reverse order using the for loop. And for your kindly note, this generator functions not only work with string but also with other kind of iterables like a list or tuple or anything. Okay, fine. So see here, dear friends, the exact word hello, it had been printed in a reversed order. Okay, let me just make it with an Python generator expression. Simply, generator can be easily created on the fly using generator expressions. It makes building generator easy. Similar to the lambda function which creates an anonymous functions, generator expressions create anonymous generator function. Okay, so the syntax of this generator expression is similar to that of list comprehensions in Python. But the square bracket which we just specify here, the square bracket are replaced with rounded parentheses, only the thing for generator. The major difference between list comprehension and the generator expressions is that a list comprehensions produces the entire list, while the generator expressions produce one time at a time. So one item at a time. So this they have lazy execution, which we just say producing items only when asked for. So for this reason, a generator expression is much more memory efficient than an equivalent list comprehension. And let I just execute it, dear friends. Kindly have a look of this. So we are just having this generator where we need to make it with the list functionality, and here we are just squaring each of them by using list comprehensions, and there we make the generator. And see, we can see the above this generator expressions did not produce the required results immediately. Instead, it returned a generator object. It returned a generated object which produces items only on demand. So here how we can start getting items from the generator. So let me just see here. Whenever we need it, we are just need to ask it. And see here, this is the one. When we need, yeah, print the next year. When we need this, yeah, print this. So that is what we are just going to make it. So when we need it, we are just going to make use of it. And see here, dear friends, once the generator, here we just got an error. Why? Because see, and kindly just have a note of it, dear friends. We just have only the list is 1, 3, 6 and 10, and when we just make use of that, yeah, here we are just getting it, and we are having an error here. If we want to make it print, yeah, anyhow, if we are just making use of print, there is no element in the list. So see here, even though if I just give the print of that exact function, it's just going to give the sorry, okay, it's just going to give the error because there is no element after that. So here after this we are having only this much number of elements. And see here, dear friends, when we just need from this functionality, yeah, we can just expect any number of functionality from this my list. And see here, we can just make whenever we know, we can make use of that a here 146, and again one more, we can just make use of the max and to find which is the highest among the element. Yeah, it is 100. So this is how we can just create a list, and from that we can make use of this generator as a function. And there are so many things that we have to make use of. What is the main use of this Python generator? See, there are several reasons is there where that make generator a powerful implementation, and the first more main is easy to implement. See, actually generators can be implemented in a clear and concise way as compared to their iterator class counterpart. So see here, it is an example where to implement a sequence of power of 2 using the iterator function. So this exact iterator function, kindly have a note of it in this iterator function. So this is how the iterator function is. I just give you one more, yeah. So here it is the, okay, here it is the generator. And see, this is the exact iterator where here we are having an initiation, that is the constructor is there, the double underscore iter and double underscore next is there, and there after that we have to rise a stop iteration, and then it returns the result value. And when coming to this generator, yeah, it's very easy. And see, when comparing to this lengthy and confusing, let's do the same thing using the generator function within a simple values. And since a generator keep track of details automatically, the implementation was conscious and much cleaner. Okay, next one is memory efficient. And see here, dear friends, a normal function to return a sequence will create the entire sequence in memory before returning the result. So this is a overkill if the number of items in the sequence is very large. And generator implementation of such sequence in memory friendly and is preferred since it's only produce one item at a time. Next one is represent infinite stream. And see here, dear friends, generators are excellent mediums to represent an infinite stream of data. So infinite stream cannot be stored in memory. And since generator produce only one item at a time, they can represent an infinite stream of data. And see here, this is the exact following generator that can generate all the even numbers, at least in theoretical manner, just makes an functionality. Okay, so as an infinite stream. And last but not least, the pipelining generator. See, actually, dear friends, multiple generator can be used to pipeline a series of operations. So this is because the exact actually, how come we can just say it can be illustrated in this example. See, suppose we have a generator that produce the numbers in the Fibonacci series, and we have another generator for squaring numbers. Okay, and if we want to find out the sum of the square of numbers in the Fibonacci series, yeah, we can do it in the following way. So by pipelining the output of the generator function, yeah, it is very, very easy, and this was Bill's illustration of this thing. And kindly have a note of it. The Fibonacci series and each and everything, it just makes a square of it. So how would you just make the use of generator is the, so this pipelining is efficient and easy to read. And yes, yeah, it's a lot cooler thing to make use of. Why the main use of this generators? Okay, dear friends, have kindly just make use of the exercise and hands-on. For your information, I'm just including every codings whichever has been made as a description. Kindly just check the description. I am just including the source code of this programs in the GitHub repository. Kindly make use of it and get experienced to the every examples. And do you have any comments or any doubts to be clarified? Kindly mention it in the comment box. Thank you. Have a nice day, dear friends.